So rationalizing the denominator, this one's a full root, and you know, if you're like, you know what, I really would like to separate these, and feel free to do it. Now you can do that and then work from there if you want to. I wouldn't, and here's why. Is because you got some y's and b's right here that should undo each other or become phantom ones with each other, or in other words, you can apply the exponent rules on these. So that's what I'm going to do. So I'm going to go down this way. I will work from within. Now the 2/7, I don't see that can be simplified, so I'm not going to worry about that. We will later. We will worry about it later, but not right now. Okay, so again, just focus on one part at a time. So I'm going to focus on my y's. Okay, now that would be a y. This is division, so I know I'm subtracting the exponents. That's going to be 9 minus 4, which will end up being y to the power of 5. Okay, so that's my y's. That'll be in the square root, which I'll show here in a second. And then I've got a base b with the power of, and they're dividing the bases, so we're going to subtract the exponents, 2 minus 7, which would be b to the power of -5. Now this -5 here tells us that it just goes in the denominator. So right now I have the square root of 2/7 y to the power of 5, b to the power of -5. But I'm going to rewrite that as still a square root, but as a fraction. I got the 2/7, but in the numerator would have y to the power of 5. In the denominator, since it's b to the power of -5, I can just put that in the denominator. Now I got a positive exponent right there, which is good. Now, at this point, I would separate them, the numerator and denominator.
What was the b to the power of negative?
I made this a positive 5 exponent. Some students could work with that negative exponent, -5 exponent. But I prefer to see it like this because I can see right here that I can actually pull some b's out of that denominator, right? So at this point, of course, there's still lots of different directions you can go from here. But I'm going to separate these, okay? So I got my numerator, which is 2 times y to the power of 5. And this is all over the square root of 7 times b to the power of 5. Now you can rationalize the denominator one value at a time, meaning if you want to rationalize the 7 first, feel free to do that. When you do so, you should end up with, in the denominator, just a regular 7, not square root of 7. So how do you take a square root of 7 and make it a regular 7? You'd multiply it by the square root of 7. See, because this is the square root of 7 times 7, that's the square root of 49, which is this 7 right here. But if you do it to the denominator, you must also do it to the numerator. So I'd have to take the square root of 7 times 2, which would be the square root of 14. Gonna move that over a little bit. Sounds a little bit extra space. Okay, so that's nice, but what about the b, right? Because we don't want that b to the power of 5. Well, this is really the square root of b to the power of 5, which is also b to the power of 5 divided by 2. And that then would be b to the power of 2 with a remainder of 1. So that would be, in other words, b squared times the square root of b. I did skip some steps between this one and this. Okay, so from there, I don't need to get rid of the b squared, right? That's rationalized. It's the square root of b that I've got to get rid of, essentially. And so at this point, I would have to multiply that by the square root of b. But if I do it to the denominator, I must also do it to the numerator as well. Okay, so that's the square root of b times the square root of b, which is the square root of b squared, which is just another b. So let's see if I can gather my work together here, make it look a little bit more pretty, a little bit. And by the way, I still have that square root of y to the power of 5 in the numerator.
Are you taking out the b? Why are you taking out the b?
And that's shown in this work right here, the square root of b squared, which is just b. So what do I got now? So from here, in the denominator, I've got 7, and I'm going to show more work here, but I've got the b squared and the b, so that's 2 b's I got a b squared and a b in the denominator there. So I'm gonna combine that into a b to the power of 3. So I still got my 7, but that'd be b to the power of 2 plus 1, which is going to be b to the power of 3. Now that did rationalize the denominator, but what do we got in the numerator? We still got to worry about that stuff, right? So let's work in just the numerator. So I'm going to have my square root, and I've got my 14, and I've got my b, right? Let's look at this square root of y to the power of 5. And again, we should always be looking to simplify if we can, but this would be the same. What the heck, I'll use purple. So that'd be y to the power of 5 divided by 2, which is the same as y to the power of 2 with a remainder of 1, right? 5 divided by 2 gives you 2 remainder 1. So that would be the same as, I have enough space, yep. That'd be the same as y to the power of 2 with the square root of y. Okay, so from here, then, I've got my y to the power of 2 in my numerator, but I still have a square root of y which needs to go in the numerator. So let's write that out here where it's been simplified. 14. Yeah, so it's pretty ugly, by the way. Some students would say, wasn't this prettier than this one? Perhaps. But that's not what they want. They want this rationalized in the denominator. So we got y squared, square root of 14, by, all over, 7b to the power of 3. And as much fun as that was, because you enjoyed it so much, that's as far as we need to go. These types of problems, it's all about what are we trying to get out of this? And it's like the answer to me, it's pretty ugly. It's a pretty ugly answer. But it's about getting that square root out of the denominator. So yeah, even at this point, multiplying by square root of y, you'd have to multiply in the denominator, which places that square root of y back into the denominator, which we don't want. And so again, our goal was just to make that denominator not have square roots. And again, you're now equipped. You can see, you can work with the numbers, you can work with the letters. If we had kept the y's here in the denominator, by the way, you could work with that as well, right? You could say, well, this is y to the power of 4, which would have been y squared, and then y to the power of 9 would have been a y to the power of 4 here, and then 4 minus 2 would have given you that y squared in the end anyways. But then you would have had the square root of y in the top. Is that a better method? I don't know. Again, it's just a different path to take to get to the final answer, but all of those work within the rules that we have, right? And that's the main thing is the math. It is what we want it to be if you'll take control of it using the tools that you have been equipped with now.